So we're going to be doing problem number 6. Here are the problems. It says indicate which set of numbers each of the following belong to and list all sets to which the numbers belong. So let's just start by saying every single number up here is from the real numbers. In an algebra, beginning algebra class, that is the only set of numbers that we usually deal with for the entire semester. So all real numbers up here. All right, the next thing that we look at here is this first one. It is an irrational number. An irrational number is a number that cannot be created by a fraction. Many of the radicals are irrational numbers. Not all of them, but many of them are. And therefore, a lot of students will get confused between A and, say, B or D. But this one is irrational because there is no number that, when multiplied by itself, will give you 11. 11 is a prime number. So it is irrational. Moving on to B. In part B, we have another radical. However, this one is not an irrational number. 36's square root is 6 because 6 times 6 is going to give you 36. And so this is negative 1 over 6. This is a quotient of two integers and therefore is what we call a rational number. Moving on to part C. A lot of students will confuse this one because they know the approximation for pi is 3.14 and therefore they associate this number with pi and they know pi is irrational, so they'll tell me that this one is irrational. It is not irrational. It is a terminating decimal. All terminating decimals are rational numbers because it can be written as a quotient of two integers. This can be written as a quotient of 314 and 100. So it is a rational number. Finally, moving down to my part D. Again, we have a radical, but this one is not irrational. It is again rational because 3 times 3 gives you 9. So the square root of 9 is 3, and then it's a negative number out here. So this one is a rational number, but it is also an integer. So this is both rational and an integer. Recall that integers are the positive numbers and their opposites and 0. So this one is an integer. It is one of the opposites of the whole numbers or opposites of the counting numbers.